Hello viewers, today I will explain the working principle of a DC generator and uh, the construction of DC generator, etc. So the working principle of DC generator, which is similar to the alternator. So the DC generator is nothing but a alternator plus commutator. So the sum of these two is called as a DC generator. So the working principle is Faraday's Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction. So in these two laws are there, first one and the second one. So according to the Faraday's first law, what is saying? Whenever, for example, if you take two poles like this, if you take north and south two poles, so we know that one from the basics, flux always flow from north to south like this, north to south, and this north and south are two permanent magnets. So always flux flows from north to south, and if you this is the conductor, this is which is shown in the red color. So according to the Faraday's first law, whenever this is I am taking as conductor, so this is a conductor I am taking. Whenever, according to the Faraday's first law, whenever conductor cuts the flux, nothing but if you rotate this conductor or vertically move upward and downwards, you can cut uh, the flux will be cut by the conductor. So whenever conductor cuts the flux or flux cuts the conductor, so whatever it may be, either of one is stationary, either flux stationary or conductor stationary. So both moving is not possible, so that either of one is stationary. Whenever conductor cuts the flux or flux cuts the conductor, then EMF induces across this conductor, and EMF induces across this conductor according to the Faraday's first law. So this is Faraday's first law, and what is the Faraday's second law? According to the Faraday's second law, induced EMF is directly proportional to rate of change of flux linkages d phi by dt. So the magnitude of the induced EMF is directly proportional to rate of change of flux linkages. First law clearly explains how the induced EMF. First law explains how the EMF induces across the conductor, and the second law explains how much EMF, induces. So the Faraday's explained clearly how the EMF induces across the conductor, and how much EMF induces, and what are the factors affecting on this, he clearly explained. And the next one, so direction of induced EMF of DC generator. So direction of induced EMF. So we know that one Faraday's, according to the Faraday's clearly explained and how the EMF induces across the conductor, but he didn't explain how the direction of induced EMF. So Fleming's explained Fleming's right hand rule. So this is not a law and this is not a theorem. So this is a rule. This is a rule. Fleming's invented this one. So according to the Fleming's right hand rule, so keep your right hand. So assume this is your right hand. This is thumb. This is forefinger, and this is middle finger. So like this. Like this you should keep. So according to the Faraday's Fleming's right hand rule. So Fleming's right hand rule is for generator. Fleming's left hand rule for motor. So generator for uh, right hand rule for DC generator, and left hand rule for DC motor. So according to this Fleming's right hand rule, So I will explain clearly how to express this Fleming's right hand rule. So uh, we are discussing about the Fleming's right hand rule, nothing but a generator. Generator, the intention of generator is to produce the EMF. But according to the right hand rule, this is the motion, thumb indicates the motion, and middle finger indicates the induced EMF, forefinger indicates the magnetic flux. But according to the Fleming's right hand rule, so this is belongs to generator. So generator intention is to produce the EMF. The generated in intention is to produce the EMF. So first of all, we should keep flux will be like this, north to south flux flows will be like this, and after between the flux, if you move the conductor between the flux, this is the flux between the flux, if you move the conductor, then EMF induces. This is the third one. First you should express magnetic flux and motion, and then induced EMF. This is the sequence we should remember. So according to the right hand thumb rule, so we should express like this. We should keep thumb, this thumb and forefinger and middle finger mutually perpendicular to each other. We should keep thumb, forefinger and middle finger should keep in a mutually perpendicular to each other. Then first one is we should express the magnetic field. So forefinger indicates the magnetic field, and the thumb indicates, the second one is thumb indicates the motion of the conductor. Then we should say then the middle finger indicates the induced EMF. So first we should express flux. Whenever the we should keep these three fingers mutually perpendicular to each other, and then the forefinger indicates the direction of flux, and the second one thumb indicates the direction of motion. Then the middle finger indicates the direction of induced EMF. This is a way to express the Fleming's right hand rule. So we should not express these three fingers in a random direction, a random sequence. We should express in a sequence manner. First magnetic field and then motion. Then only induced EMF exists in the middle finger. That's why we should express in this way. And the next one. So direction of induced EMF also expressed in explained in a different person. That is nothing but a right hand palm rule. So according to the right hand palm rule also, uh, so we can express the direction of induced EMF. So right hand palm. According to the right hand palm, we should keep thumb in the direction of north to south flux flow direction, and remaining four fingers direction should be in the induced EMF direction. Then palm indicates the direction of motion. So we should keep this hand like this. This finger indicates the direction of flux, and these remaining four fingers indicates the direction of current. Then the movement of the hand upwards indicates the direction of motion. So this is the right hand palm rule. So this is the uh, another way of expressing the direction of induced EMF. But according to the right hand thumb rule, this is the expression. So this is the flux, and then motion. This will be the current carrying. So this is also another way, and this is right hand palm rule also another way of expressing the direction of induced EMF. And next one, the construction of DC machine. So why I am calling as a machine? Because DC machine is nothing but is a generator or motor. Because the construction of both DC generator and motor both are same. That's why I call that as construction of DC machine. So already explained working principle, and according to working principle, and definitely the DC machine contains poles. north south north south in a sequence manner. So actually I in the working principle, in the working principle, these are the two permanent magnets, north and two, these two are the permanent magnets. But that is only for the understanding purpose I took permanent magnets. But actual construction of DC machine, there is no permanent magnets. These two, north south, north and south, these are the electromagnets. Electromagnets, these are the electromagnets, nothing but we know that one, in the presence of electric field, these rods, these act as a magnetic magnets. So in the presence of electric field, in the presence of electric supply, these act as a magnets. And this is nothing but a stator, nothing but stationary parts, and poles are fixed to the stator. So these are the interpoles, nothing but the poles are between the main poles. This is also called main poles. And these are the interpoles something between the main poles. We are placed these interpoles, that's why these are called interpoles. And how the interpoles are placed I will explain later. And this is stator, and this part is called yoke. This is called yoke. And this is the curved shape, this is called pole show. So this is explained here, this is pole show, this is called pole show. And this is the iron part, this is nothing but pole core, that is nothing but a pole core. So this is exactly, this is pole core. And this pole core act as a magnet if you place the winding like this. If you place the winding like this, and if you give the supply to the pole, this is a pole winding, field winding, we can call that as a field winding. So this core will be surrounded with this winding, this core is surrounded with this winding. And we should give the supply, that is nothing but a DC supply, which if you give the supply, this act as a magnet, and flux flows from north to south, like this, and again south to north internally. So this is pole core, this is pole shoe. And to produce the flux we are placing this winding, that's why this is called field winding. This is called field winding. I will explain everything by individual, and then you can understand easily. I'm explaining the parts now. And this is armature core. So this is armature core, and between the armature slots we should place the winding. Because whenever conductor cuts the flux, we should place the winding in such a way that that conductor should cut the flux. So if you place the winding here, if you rotate this rotor, it will cut the flux from passing from north to south. So that definitely conductor must be placed between the slots. These are the slots. This is the armature, and these are the slots. Nothing but these are the slots. Between the slots we should place the winding. And after placing the winding, we can if you rotate the machine in the presence of a magnetic field, that will produce the electricity, and those electricity will be collected by the commutator. So commutator, this is the commutator. I will explain individual parts. And from the commutator we should provide the brushes. From the brushes, total current will be collected and sent to the at a particular battery. So these are the main parts. And this outer parts is called yoke or frame. And this is the field winding which we should place to produce the flux. And these are the commutator segments where the current will be collected. And between the north and between the poles we should place the interpoles. And between the slots we should place the in the armature slots we should place the conductors. Such a conductors are called armature conductors. And this is the shaft are nothing but where the rotor is rotating, and standby which is called a shaft. And this is a curved shape is called pole show, and this is called pole. These are the uh, main parts of the DC generator, and I will explain individually. First of all, the stator. Stator is nothing but a stationary part. So in that, the first one is a yoke. This is called yoke. This is the actual generator, and this is called yoke. So this is the outer part of the stator is called as a yoke, and this stator having different parts. So these supporters are called feeds, and outer parts is called frame. This is lift to high, nothing but where if you want to change its location, we should use lift high. And this is the terminal box. This is the box where positive and negative supply is provided at the terminal box. So these are the yoke, and the function of yoke is the yoke is made with first of all the material used is silicon cast steel. Cast steel is a material which is used to construct a yoke, and the yoke act as a return path to the flux. Return return path to the flux. Nothing but we know that one flux always flow from north to south like this. Flux always flows from. So I will take a bigger one so that you can understand easily. So flux flows from north to south like this. North to south, and the return path from yoke like this. South to north internally. So the yoke will provide the return path to the flux. Yoke will provide the return path to the flux, and also it will supports the field winding, field core, armature, field core. It will be supported by the core is supported by this yoke, and the next part is armature. So armature is nothing but actual armature will be like this, and these are holes. We can call that as air holes. We can call that as air holes. So air holes are used to send the air through it, so that the temperature which you will produced by the eddy currents will be reduced by these holes. So generally eddy current losses will exist in these armature slots, and those losses will be reduced. Due to those eddy current losses, temperature will be produced in the armature slots, so that by providing the air holes, some air will be sent to the naturally through the air holes, and temperature naturally due to the natural air, temperature will be observed from the armature slots. These are the slots. Slots are nothing but just like a textbook. So if you take a textbook, individual papers will be there. So by adding more number of papers, you can make a textbook like this. These are the small plates like that. By putting all the slots together, we will make a armature core. So armature core, why we are providing the slots means to reduce the eddy current losses. So by reducing the to reduce the eddy current losses, we should provide the laminated slots. So between the slots we should place the insulation. Then only we can reduce the eddy current losses. The material used is to construct the armature is silicon steel. Silicon steel is used to construct the armature, and these are the slots where we should place the winding like this. We should place the winding like this. So between the slots we should place the winding in this way. So more number of winding turns we can place. in the between the slots. And here the type of slots are open type slots. This is open type. So different types of slots are available: open type, closed type and semi open types. But in the DC generator we should use uh, open type slots. By using open type slots we can increase the average induced EMF. Average induced EMF we can increase. And with these open slots, the induced EMF is nothing but flux distribution is flat tapped. Flat tapped. So that this is flat tapped is which is nearer to the DC. That's why open slots are preferred. So this is the construction of armature. And the next part is armature winding. So the armature winding, is placed between the slots. So I forgot to say one thing. So these slots actually not in a parallel manner. The slots are not in a parallel manner. Actual slots will be like this. Actual slots will be skewed. Skewed nothing but actual slots will not be parallel to each other like this. These are skewed with a certain angle. Skewed certain angle like this. You can see here slots are skewed. So why slots are skewed? So the answer for this question is whenever the rotor, this is the rotor, whenever the rotor is rotating, so to reduce the mechanical vibrations we should skew the slots. We should skew the slots. So mechanical vibrations will be reduced by skewing the slots. So we should not place the slots in a parallel. We should place the slots in a skewed manner so that we can reduce the mechanical vibrations. Next one is armature winding. So armature winding is nothing but armature winding placed between the slots. I explained already. So these are the armature winding which is placed between the slots like this. So this is armature winding is two types. And first one is lap winding, and second one is wave winding. So wave winding having only two parallel paths, and lap winding is equal to parallel paths is equal to number of poles. Number of poles is equal to number of parallel paths. And in the wave winding, EMF will be more. If you want more voltage, we should use wave winding. If you want more current, we should use lap winding. So we can understand this one in the winding procedure of DC generator. So I will explain later. And the next part of the armature is commutator. So commutator, you can see commutator here. So these are the commutator segments. These are the commutator segments. And these commutator segments are made with, so you can see the color, aluminum or hard drawn copper. So this commutator are made with aluminum or hard drawn copper. So these are the materials which is used to construct the segments, and each segments are separated by some insulating material. So this insulating material is called mica. So this insulating material will not allow to flow the current from one segment to another segment. And this commutator will converts the AC. Actually, the induced EMF in DC generator internally. So internal induced EMF in DC generator. DC generator is AC. So whatever the induced EMF internally it is generating, whatever the current is circulating internally in the DC generator is nothing but a AC. It is not a DC. It is a AC. But in the commutator, it converts AC to pulsating DC. Pulsating DC. If you use more conductors, that will turn into pure form of DC, no problem. But if you use 2 or 1, 3 less number of conductors, it will convert into pulsating DC. And if you use more number of conductors, it will converts into AC into pure form of DC. This is the function of a commutator. And the commutator for DC generator, so DC generator, it converts AC to DC. For DC motors, it converts DC to AC. So DC to AC to DC is nothing but rectifier. The function of the commutator in DC generator is AC to DC. AC to DC is nothing but a rectifier. But in DC motor, which converts DC to AC, nothing but inverter operation. So in DC generator, commutator function is rectifier. In DC motor, commutator function is inverter. So we should remember these important points, which will help you in further education. And the next part of the DC generator is brushes. So I already explained in the single loop generator, brushes are used to collect the current from commutator. So this is the function of brushes, and actual setup of the brushes will be like this. So this is a spring which will always pushes these brushes towards the commutator, and this is flexible pigtails which is easily collect the current from brushes. So the brushes material used for the brushes is carbon, and for small machines we should use carbon, and for large machines electrographite for large machines. For the large machines, the brushes are made with electrographite, and for small machines, carbon material is used, and these are the brushes. And so these are the main parts of the DC generator, DC machine, and so this is all about the construction of DC machine, and the working principle of DC generator, and the direction of induced EMF can be found by using Fleming's right hand rule, and also right hand palm rule. And I explained each function of DC machine part.